Okay, so let's start the very final plenary session of this wonderful workshop. So it's a pity that we are approaching the end of this workshop, but don't worry, we still have two excellent speakers. The first speaker is Professor Nivaldo Grulla from ICMC. And he is going to talk about two pairs, the same numbers, and what survives anyway.
Thank you very much, Professor Osamu. I'd like to thank the organizers for the opportunity to talk here. But before I start my talk, on behalf of the Singularity Theory Group of São Carlos, we would like to say some words. Of course, all you know that this workshop is dedicated to Cidinha, but we also want to make a tribute and honor many of our friends and colleagues that also passed in these last years. And we would like to thank for the legacy, contributions, and shared memories. Well, so I would like to say some words about Cidinha, and I had to write, otherwise I think I would be able to finish. So I wrote something that I would like to read for you. Few months before Cidinha passed away, I went to the restaurant at UFSCar to have lunch with a friend who was spending a day at the Department of Psychology. Shortly after we arrived, Cidinha and Gaspar came in with a few friends. I went over to their table to greet briefly, and while we were serving ourselves at the buffet, I exchanged a few words with Cidinha and Gaspar. When I returned to my table, I told my friend who was that lady, explaining that she had been my PhD advisor, and he replied, I thought it was something like that. I noticed that you seemed a little bit nervous while you were talking to her. Then he asked, has it been a long time since you last saw her? And I answered, no. My office is only 2 or 3 doors away from hers at ICMC, and often we have coffee together. We also have a weekly meeting because we are finishing a paper together. He looked at me surprised and asked, then why are you so nervous? And I replied, for me, meeting Professor Cidinha is always an event. I would like to try to explain you in just a few minutes why it has always been such an event for me to meet her. My first direct contact with Professor Cidinha was during my undergraduate studies. She was my professor of topology, and I believe it's not a coincidence that now I work in topology of singularities. Of course, I already knew who Professor Cidinha was, but beyond all her reputation and prestige, I was deeply impressed by her dedication and availability. I was already close to finish my undergraduate studies degree and was very interested in pursuing graduate students. Naturally, I want to ask Professor Cidinha to supervise me. When I shared this intention with some people, I was strongly discouraged. They told me that Cidinha only advised the very best students. To be fair, my academic records was far from perfect, and my mathematical journal up to that point had already gone through difficult moments. Today, I'm not entirely sure what gave me courage to speak to her. Perhaps it was precisely the openness and availability that she always showed toward us. And what a joy it was when she accepted me. Sometime later, she told me something in a way that many of Cidinha's former students will immediately recognize. Nivaldo, I think you should go directly to the PhD program. Once again, I heard people saying that I should not do it, that if if things did not work out, I would not even have a master's degree. But it made no sense to me that Cidinha would be involved in a project that would not succeed. And so I began my doctoral studies. I still remember the first time I was invited to have dinner at Cidinha's house. I was so nervous. I was afraid to do something wrong, say something inappropriate, or simply not behave as the occasion required. To these days, I'm not entirely sure that everything that I put in my plate that day was actually food. I strongly suspect that part of what I ate consisted of decorative elements. Cidinha built many bridges for me. First, she put me in contact with the renowned Professor Brasilet, who later became my advisor in a Cotutel PhD program. And she also introduced me to many other researchers around the world. But I never forgot that bridges are built not only, sorry, but I never forgot that bridges are built not only so that we may live, but also that we may return. And whenever I could, I tried to return and remain close to her. From every From very early in our careers, we are told that we must demonstrate independence from our advisors, that we need to prove to others that we can walk on our own. Yet, even as I felt confidence and take my own steps and following my own path, I knew that the journey would not be the same without her. I built my independence, but I confess that without any concern for appearances. It has always been a source of pride for me to be recognized as one of Cidinha's students. And beyond that, it has always represented a great responsibility. Of course, when I was young and at the beginning of my career, I dreamed of proving theorems that would change paradigms, publish in high prestigious journals, and perhaps even win an important prize. What boy have never dreamed of playing football or soccer for a great team? That was my way of dreaming. But with time, I came to understand that I would probably never prove a theorem that changed the paradigms, that perhaps I would never publish it in the journal of my dreams, and that I would likely never receive a major prize. In those moments, I often asked myself, what did Professor Cidinha see me? I often ask myself, what did Professor Cidinha see in me that led her to accept me? By walking alongside her, however, I came to understand that despite having papers in major journals, international awards, and worldwide recognition, she did not do mathematics because of those achievements. She did mathematics simply because she loved it. And I believe that this is what she saw in me. As legitimate and natural as it is to aspire to such recognition, true joy lies in witnessing mathematics move forward day after day, and in feeling that somehow we are part of this endeavor, in loving it deeply, and in perceiving the beauty that resides within it. I'm not saying that Professor Cidinha did not believe that I could achieve those things. I am fully aware that she saw in me much more potential than I ever saw and perhaps still see today. But I'm convinced that she saw in the sparkles of my eyes that I would be happy doing mathematics. And as always, she was absolutely right. So today I will share with you some ideas and some questions that I'm interested in and work it seems some time recently. And I will start just with basic questions. So in singularity theory, one of the basic things is to try to take different germs and have some tools to say if they are equivalent or not. And one of these tools that we know is the Milnor number. So we know that we can compute this number, and if two germs with isolated singularities here, and we are talking with examples in situ, if this number are different, so they are not equivalent. In some sense, geometric sense. But we also know that we can have singularities that they could have different geometric type, but they have the same Milnor number. So just use the Milnor number. It's not enough to to distinguish all the situations. So this naturally leads us to a question. Can we find another invariant? Could we find another invariant that could help us to distinguish two germs of functions that are, in some sense, different, geometrically different? So do you want $1 or a mystery invariant? I don't have $1 for everyone, so I will give you the mystery invariant. So the invariant that I would like to talk to you, I think some of you already know, is the log canonical threshold. And what I use it in the problem that I'm trying to work is the real log canonical threshold. So this number, in some sense, it controls two fundamental asymptotics. So it's related to a question about if you take a function and a power minus c, and we want to find the threshold where this integration does not blow up. So we have this control with this number, and also to control the vanishing of the volume when you approach to the zeros of our function. So we take a kind of neighborhood, and we want to see what happened when this neighborhood shrink to the zero of our function. So this invariant, the LCT, is very important in birational geometry, and it became a fundamental tool in modern birational geometry, particularly in the minimal model program. And also, the real, how can I say, version of this invariant is related to statistics, and in some sense, it controls the complexity of the models and is related to machine learning and neural networks. So this is one invariant with many communities. So as far as I know, the first works on this invariant started with Atiyah, and also with Arnold and Varchenko, and we have a lot of things did by Shokurov, Kolar, and Mustata, and recently these applications in deep learning by Watanabe. So in general, we define the invariant and compute afterwards. I will do the opposite. I will just make some computations with some examples, and after that, we will understand better the definition of this invariant. So first, I will use a very nice formula, but to use this formula, we will see two examples of functions that are Newton non-degenerate. And in fact, we have some technical conditions that we need to choose this formula, but these two examples fulfill all the conditions. And to compute this, we need a number that is the Newton distance. So the Newton distance of a Newton polyhedron will be the distance from the origin to our board of our Newton polyhedron, where we will just use the diagonal as line to touch the board. And there is a formula by, we say, Kushinerenko, Varchenko, and others also worked on this and looking in this perspective of LCT, that the LCT is 1 over this distance in most of the cases, and the cases where we want to compute here. So the LCT that is complex, in the complex case, it's not always the same number as the RLCT. We need some conditions to have this. In fact, there is a paper of this year with conditions that ensure that these two numbers, when these two numbers are identical. But for the examples that I will show here, we have this coincidence. So, for example, if you have F1 that is x to power 2 and e to power 6, so we can compute our invariant only by take this line, and we compute this distance here, and in fact, it will be 1 over this distance. So in this example, we can simplify, make the computations, and we can find the distance, the Newton distance here. And in this case, we have the LCT is equal to RLCT. Then we have that the RLCT of F1 is 2 over 3. And we can take, for example, this F3, x2 e plus e to 4. And we can also make the same computations. And we will take here this distance, and making the computations, we'll take that this distance is 8 over 5. So we have that the RLCT is 5/8, okay? So, okay, the RLCT, in this case, can distinguish these two numbers, these two germs, and the Milnor number couldn't do that. But it is enough to proceed and use this invariant. In fact, it's not enough, at least in the way that I was trying to work. So we have some limitations of this number. And for example, if we take two normal surface, we can find examples where we have the RLCT of both the same, but that geometrically we can see that these two surfaces are not equivalent. So we can have surfaces with the same invariant, but different geometries. In fact, what we can construct is a whole spectrum with many information, many numerical information that encode the geometrical information of our variety or surface in this case. But so in some sense, if we have these numbers that are different, we can distinguish some cases. Because if we have more numbers, so we have more information, and we can have know more about the geometry. But even this is not enough. So if we have a list of numbers, and in this case, this information came from the divisors of our resolution. So these numbers is taken from each divisor one by one. So we have this information, this numeric information, but only the number does not tell us how the divisors intercept each other, for example. So we could have two whole spectrum of x1 and x2, but the geometry of both could be different. For example, we could have in a situation two graphs, resolution graphs. For example, here we have 4 divisors, representing 4 divisors, and we could have the same number for this information. But when we look the graph, in one side we have a tree, for example, and in the other side we have a cycle. So we can have the same numerical information, but different geometry. So what I try to do using this numerical information. So we have this list of numbers, but I want to look beyond this numerical information. So we tried to attach some topological information related to these numbers that are intrinsic. So these numbers are intrinsic to our variety, our surface in this case, and we tried to attach some topological information. So this is the idea of what I defined as divisorial asymptotic homology. So what is the formal setting? So I have analytic pair, that is the object that I want to study. So if I have an analytic pair, I can construct a function, an energy function, that is defined as the sum of each generator of my ideal to the power 2. And I can define some neighborhoods, as I told in the beginning, some neighborhoods that shrink to the variety defined by the zeros of my generator, my ideal. And I can study as in the beginning, the integration of this function and how the behavior of these neighborhoods, what we can understand by our singularity, understand how these neighborhoods shrink to the origin. So, and that is the data that I will need to define this homology. So when we have a log resolution of our pair, we have a very strong situation that when we have this composition here, our function on the resolution is monomial. And when we look for the, how can I say, the correction of the Jacobian, the determinant of the Jacobian of our resolution, we also have this monomial way to define. So we have a very simple situation for integration in this when we apply this log canonical resolution. And these two exponents is the numbers that I will need. So when we have a resolution, what is happening is that I'm trying to understand the behavior of these integrals near to the divisors. The divisors, in some sense, can be seen as the locus that concentrate the energy of our function. So that is what we are trying to understand. But when we work here in a neighborhood here, our function is very easy to integrate. So we have for a neighborhood in the divisor, we can look our function this way, and the distortion, that's the word that I forgot. So the distortion of the volume here, we can look in this way. So together, what we define is an asymptotical exponent. And I will just give the idea for the model when I have just one divisor. We can make the integration of this function that is monomial and just make the computations. We'll have as the threshold for our integration exactly this configuration of number. So we have for each divisor, we can have this threshold defined by this intrinsic information. So the numbers attached to each divisor, it's not arbitrary. This number is not something that I just choose, but is the asymptotic rate at which volume near the divisor disappears. And if we have more divisors, so we have the same idea, of course, but we can have some correction here if we have more than one divisor with the same exponent. But we can control what is happening near our divisor. So in some sense, we can say that exceptional divisors govern exactly asymptotic rate of concentration near the singular locus. Okay, so these are the exponents that I work, and using these exponents, I can try to understand geometry of our object. Okay, so as I told you, we had numbers. So let's change a little bit the question. So instead of asking how singular is this germ, we can ask what geometric information survives as we approach to the singularity. So we have some shapes that we can, for example, think in chains and cycles, so we can try to understand if we could have some kind of homology in this situation, okay? So the asymptotic conditions that will appear are volumetric in nature. So to make the details, the technical details, we use subanalytic singular chains. But basically, by subanalytic triangulation, we have that no topological information is lost in this change. So the question is, how much of a chain survives inside this neighborhood as our epsilon goes to 0? In other words, what topology is left behind as we shrink? So to define the elements that we want, so we define alpha admissibility. That is, we'll say that our chain is admissible if we have alpha admissible, if we have a constant C, that this integration is less than this number when epsilon is small. So alpha measures the rate at which a chain disappears inside the shrink neighborhood U epsilon. So with this, we can define a chain complex. So we can define this chain complex, and we can prove that when we use the board, we remains with the same alpha, and we go down from 1. And with this, we can define the asymptotic homology, just in take the homology using this chain complex. So if we have two numbers, two positive real numbers, beta and alpha, so we have the condition is strict, so we can compare if beta is bigger than this, so we have this group inside this, and we can define a map from one group, holomorphic group, to the other. So as we have this complex chain, so we have this homology, and the very interesting point is that this alpha is not arbitrary. I could, and we have this definition for any alpha that's a positive real number, but in fact, when we work with this definition, we realize that the alphas that really matter are the alphas that are given by that exponents that I showed for you before. So to make this this more clear, we can define a kind of invariant that will read which is the correct admissible rate for each chain, and this number we can prove that we can read by the informations on the divisors. So we have this number that we define for all alpha, but in fact, what matters is the intersection that we have with these divisors. And that is the turning point, because all things that we defined came from analysis. So we went to divisors, and as we can compute these things only by the information by the divisors, we can have a kind of combinatory way to make the computations and study the elements that came from the analysis view of point. So using this, we have this filtration that we can think that is parameterized by alpha, that's positive, real positive. But as I told you, in fact, the numbers that matter are only these finite numbers that came from the divisors. So this approach, this definition of homology, the divisorial asymptotic homology, to persistent homology. So the persistent homology, in general, is related to a cloud of points or things like that. And here is related to information that came from the divisors of a resolution. So, and in this, we put this D to say that we are really working in the numbers that matters, that are these exponents. Okay, so just in some words, this homology records which chains survive, at what asymptotic rate they survive. So the exponents governing these rates came from the resolution information, and they are intrinsic. That's the whole idea, and that is the construction. So the mechanism is that we are working with a pair, analytic pair. We define an energy function that is constructed by a sum of the square of generators of I, and we prove that it does not depend of the way we choose the generators. With this, we construct these neighborhoods. So we have the admissibility conditions, and we define this homology. So I think that is a very nice idea, but I think most of you know that there is no so new idea here. So this admissibility condition begins with work with Goreski McPherson. So this way to adapt the homology to study singular phenomena, singular varieties, came from the work of Goreski McPherson. This idea of study this in a geometric way and this admissibility, we can, for example, go back to the metric homology of Birbrayer and Bracelet. And this idea of understand what happened when we shrink, we can also see the vanishing homology from Valette. And the persistent homology, we have a lot of tools that we can use, but that came, for example, from people that work in persistent homology, like Edelburner, Carlson, and Zomorodin. So the divisorial asymptotic homology, in fact, tried to take a bit of all of these ideas to construct something that we can understand better informations in algebraic geometry point of view, let's say, with divisors and have some intrinsic information. So, for example, vanishing homology, we have some rates, but we can choose these rates, but now they are imposed by our variety. So it's intrinsic to our variety. So we have, as I told you in the beginning, this persistent homology, the levels that survive are also imposed by our variety. So just to give an example, is that when we are in the surface case, we have a very nice theorem that we can read and can compute this homology only by the homology of the graphs, the subgraphs that we can take from the resolution graph. So taking the resolution graph of our singularity, we can compute this homology. And of course, we can have this information, as I told you, that sometimes we have the same number information, but we don't have the same topology. So with this, we can distinguish things using this construction that they have the same numbers, but different geometry. As in the beginning, when we look for this graph, that this is really the situation. When we have subgraphs, we will start, for example, with this guy, then we have another subgraph that is, we take this 2, then we take this 3, and then we take all of them, and we make the same thing here. But now the difference is that I will read this information, that I will close this cycle here, and that here I just have a tree. So same homological spectrum, we can have different graphs and different homology. So the full spectrum does not determine the homology. I really need to understand the geometry that is what happened there. So I work also all dimensions, but when we have the dimension bigger than 2, the situation is more complicated to deal with. We have some new phenomena. We have simultaneous concentration along several divisors. So I think that we can maybe use the computer to help us to make examples and make computations, but it's not so easy as the surface case. So some ongoing projects with my collaborator Thiago da Silva from Universidade Federal do Espírito Santo, we are trying to understand better this construction and trying to relate it with Riesz models and graded structures, and look for this construction in a more algebraic way. And with Márcio Diniz from UFSCar, we are trying to understand this construction also and relate this to the singular learn theory that was defined created by Watanabe, to understand if we can improve this theory and distinguish better some models. For example, in the singular learn theory, we have this numerical information about the RLCT, but we could have, for example, in one situation, just one divisor that gives this information. In the other situation, 3, 4, 5 divisors that give the same information. And as this number is the minimum of them, in 2 situations, I cannot distinguish these models. So if we use this homology, maybe we can improve this analysis of singular models. So the Miller number was not enough. The RCT was not enough. Even the spectrum was not enough. What survives anyway is the topology. And thank you very much.
Okay, thank you very much for a very nice talk. Any questions? Yeah, Presley. Please.
No? I see. Okay. So thanks, Nivaldo, for this lecture, which is quite interesting and giving ideas and problems. And of course, you related, you mentioned the intersection homology and metric homology. And maybe it's something that it recalls me when I discussed with Alain Cohn. Alain Cohn is a mathematical, working in mathematical physics. Maybe some people know Alain Cohn. When I explained to Alain Cohn intersection homology, he told me that it's normal to look at these perversities because, in fact, when you have a smaller stratum, there is a concentration of energy going to this point, to the point of the smaller stratum. and the concentration of energy is higher when you go in a smaller dimensional strata. And so I don't know if this gives some maybe explanation to you, what you are
Yes,
saying,
yes.
but it seems to me very related with this ideas of concentration of energy. I don't know.
Yes, yes, I think it's related to this. In fact, the construction that I'm trying to do with Thiago is really relating with some aspects from analysis, geometric measure theory, something like that, but to put more algebra, in fact. So, and in this theory, there is this sense of concentration of energy, and it's very related to this idea.
Thank you. I was surprised to see these things. They are new to me, and maybe can you quickly say if you're working in the real analytic setting, but in the complex analytic setting, does it relate to something else which is already known and under a different name, or what's the reason to work in the real analytic setting for you?
So for me, I'm working in the real because, in fact, how I touch these things, in fact, because I was trying to find some things in math apply and the statistic that I could use singularities. So I was trying to find something that I could apply some methods, singularity methods or things like that. And I found this work of Watanabe, where they work in the real analytic setting. So the first version that I have contact, it was this. So of course, it's a lot of things about statistics to understand, but the idea was more or less use resolution and integration and understand the systems. But when I started that, I started to make some theoretical questions and try to understand what I could do beyond. And I tried to understand this invariant. So I looked for some papers about this, and I realized that, in fact, that is a real counterpart of an invariant that in the origin is in the complex setting. So I start to read something in the complex setting and conditions that could help me to compute things in the real setting because of the applications, but using information from the complex side. So, for example, I'm working this, I think 6-7 months, so it's a lot of things, and I'm just learning. But I know that there are many applications of this number in biracial geometry, and one paper that it was one of the first that I read something about this is from Carles. I don't know if he's here, but in a paper of Carles, he touched also the LCT, and it was one of these. So, in fact, I started trying to make some applications, and the setting was the real world, let's say.
Okay, thank you.
So, in terms of what they said about the limit integral, have you seen if, in terms of geometric currents and geometric measure theory, if that limit does represent like some cohomology information, but from the current side, the integration current side of things?
Yes, yes.
And maybe related to what Alan Kohn said, is like a measure of something like information or something like that, energy information, something like
Yes,
that.
that is the language that I'm trying to learn. Also with Cisneros in some paper about currents, and that is the language that I'm also working with Thiago. That we gained some algebra, so it's very strong. Of course, we need a lot of background, so but that is the language that we are trying to adapt all the definitions in the language of currents.
Okay, thank you.
Thank you. Any other questions? No? Then I have a question. So you mentioned about application to learning theory, but also you mentioned about persistent homology. So your DAH can be used to, for example, the data analysis or something like that?
I hope so.
I hope so.
Yes, and but
So
in
there is a
fact,
possibility, yeah.
what I was trying to do when I realized this, because I was just constructing this, and I knew a little bit about persistent model, not too much, and what I tried to do, and I have some directions that I think to works, is that we have some theory that we develop the study of this persistent topology that I can apply to my situation. And for example, there are some spectral sequence and a lot of things that we can do there that I think that I can adapt and improve to compute. So I have some ideas of in the bigger dimension how we can compute and for example have some decomposition theorems and things like that that are inspired in this persistent homology. But up to now, what I'm trying is to learn more about this and apply this for this theory.
Okay, very good. Yeah, yeah. I hope there are some applications. Yeah, thank you. Any other questions or comments? No? Okay, then let's thank the speaker again. Thank you.
Thank you very much.
Okay, before starting the next talk, there's an announcement from the organizers, right? No? Or after? Not now? I don't know. Somebody told me that, no? It should be after? I don't know.
Eu acho que será mais tarde, ao fim da minha...
Ao fim
da
da
palestra. Sim, ao fim da palestra.
A fim da palestra?
Sim.
Not now. Sorry? Sorry? So I should say something? Or I don't know.
Sorry, if you bought a shirt, please get it in the reception desk.
I didn't know that. Sorry. Okay, then let's start the very final talk. The speaker is Jean-Paul Brasselet from CNRS. The title of his talk is just Cidinha. Please.
Thank you. Thank you very much. So thanks to the committees to invite me to give this last lecture. It's of course very emotional for me. It's a great honor, but also I think that quite every people here could give this last lecture. Speaking of testimony of a relationship with Cidinha, I am not the only one. And I hope each of you having my testimony will think of his or her own testimony of relationship with Cidinha. And the aim of my talk will be each of you thinking of that, thinking of your own testimony. Of course, it's when I prepared this talk, I was very a little ashamed, thinking that maybe I will speak. I don't want to speak more of me than Cidinha, and this. But giving a testimony is difficult, of course, to avoid speaking of myself. But so I am sorry for that. That I did not succeed to. But as I said, the aim is that everybody of you can think of his or her testimony with relationship with Cidinha. And I imagine Cidinha is here as her favorite place in this amphitheater at the first row. And I imagine Cidinha preparing to give me some question at the end, as she was doing quite for every talk. And and I ask myself, in fact, questions given by Cidinha were never to show that she was the best. You know, some question at the end of conferences, people want to show that they are better than the people who gave the lecture. But Cidinha was absolutely not like that. And she was always on the contrary, to give place to the speaker and to also to give some comments, some ideas to extend the result. And so it's very a model for me, a model of giving a question at the end of lectures. But let's start. So in fact, I start by why and how I met Cidinha. But the first step was sorry that there are still some words in Portuguese, but I think that they are the only one. So my first step in Brazil were by invitation of Marcos Sebastiani. I think more or less all people in Singularity know the Tom Sebastiani theorem. And Sebastiani is still in Porto Alegre, in south of Brazil. And he invited me for 6 months in 1981. And that was the first time I came to Brazil. And at that time, I had, first of all, I came to this colloquium in 1981. The colloquium was still in Poços de Caldas at that time. So it's a long time ago, when before IMPA, the colloquium came to IMPA. And at that time, IMPA was in a place in Rio, what was very strange because it was a place with full of prostitutes. And when we are going to IMPA, it was very impressive. And okay, so I came to this colloquium that year, and I discussed much more with people in topology. At that time, there was no singularity was not so strong in Brazil, and so I met many people in topology. There was Paul Schweitzer, Daciberg, Suilidruc, Saponga, many people in topology. And I came during the next years, I came in many topology meetings, EBT, and the seventh event in Encontro Brasileiro de Topologia, this meeting of topology, was in São Carlos. And I came there. I did not know that the next week there was the first workshop in Singularity. But some people in topology told me that there was this meeting. If I remember well, there was Carlos Biasi was there. Ton Marar, I think so. He is there? No? You were there? Okay. And Marcio Soares also. But Marcio Soares was not in the Topology Congress. I think he was only in the Congress in Singularity. But some people, so Ton can tell me if I mistake or not, but I don't remember who told me that next week there will be something, some event in Singularity. And so I came to the first days. It was not possible to me to stay all the week because I did not expect this. So that was the first time I meet Cidinha. And I was, one characteristic of Cidinha was, you know very well, curiosity. And soon, the first time I met Cidinha, she asked me things about characteristic classes, about intersection homology, about toric varieties. And she wanted to know quite everything at the first meeting. But after that, so she convinced me, of course, to go to the Singularity events. And I came to Singularity meetings. I think there are not many people who came to all Singularity meetings. And I think I am the only foreigner going to all Singularity meetings, but it was for me fantastic to meet a lot of people in Singularity to this meeting. So, okay. So, so I go to, in fact, I was also in a scientific committee of this meeting in 1996. ICMC was not, there was a S at that time, the S disappeared. And I was in the scientific committee, and also I was also in the topology staff, more or less. And I said, I discussed with Cidinha that it will be nice to have the two congress, the two meetings, at the same time, having conferences for both, because in topology and singularity, they are strongly related. And that meeting was a joint meeting on topology and singularity in 1996, and it was very nice because there were conferences for common and also conferences for singularists and for topology people. And but that was very nice meeting in 1996. And then with Cidinha, we decided to organize the first time the San Carlos meeting will be out of San Carlos. You know that, in fact, the topology meeting, and there was also geometry and other, I don't know other subject, but meetings in Brazil, they are moving, not always in the same city. And each time they decide what will be the next city, for example, for the meeting in topology. And but San Carlos was always in San Carlos, Singularity. And at the beginning, it was not evident to organize the workshop, Singularity workshop, San Carlos, Singularity workshop out of San Carlos. But we organized this. So Cidinha and myself, we organized in Lumini, in the CIRM in Lumini, and the name of the workshop was San Carlos Singularity Meeting in Marseille. And so there was a lot of people there. Maybe you can recognize some of them. I think the picture is too, no? So I decided to split the picture. So I will show you the left side of the picture. It's easier to recognize some people, of course, there. Maybe you are one of these people. This is the left side. Now the right side, with also some people that we can recognize, and on the central here. So it's easier to recognize people. Okay. So, in fact, at this meeting, we discussed, Cidinha and myself, of course, many subjects, and we decided also to print the abstract, the book of the conference, which was in a Birkhauser at that time. And one thing we discussed was about this guy that you have seen just before me. And we discussed, and Cidinha explained me that this guy is a very nice guy, very intelligent, and that it would be nice to have a common PhD student in a co-tutel, in co-supervision. And so we agreed. And that was very interesting that having a co-tutel, co-supervision, of course, it's if you are in different subjects, it's very nice, because I learned a lot from Cidinha. Maybe I learned a lot. Maybe Nivaldo learned a lot, certainly, but I learned also a lot from Cidinha, being in this co-supervision. And the subject, well, I will not speak to many of mathematics, but the subject was already some people spoke of this subject, that it was the relationship, for example, between local Euler obstruction and the Milnor-Bruce-Roberts number. And Nivaldo extended the idea of Euler obstruction of a function to the idea of Euler obstruction of the map from an analytic singular space to CK. And also he generalized a local Euler obstruction for K-frames. That was related with the work of Ebeling and Gusein-Zadeh. And So that is the 28th November 2007. So with the jury, in fact, it was what was very interesting. It was the first supervision, the first co-tutel in ICMC, if I remember well. It was the first that was already mentioned in I think Raoul or Thais said that. And that was a very big, very complicated way to do that, because the rules for a PhD are completely opposite between France and Brazil. For example, one example is that the president of the jury in Brazil is traditionally the supervisor. In France, it's completely prohibited. It's completely prohibited. The supervisor can be, of course, in the jury, but the supervisor cannot be the president of the jury. So you imagine what to do. We had completely opposite rules. And so with Cidinha, we decided, okay, we will present different way of the jury for ICMC and for University in Marseille. And we were very afraid, because if people were saying, administrative people were seeing that it was opposite, they will not, there will be a problem. And for the moment, no problem. So it's okay. So it was a very good experience. Of course, the first supervision, the first co-tutel, and you can see people that you recognize here, like one guy which will appear many times will be Nicolas, and other. Then in 2008, you have this big event for the 60th birthday of Cidinha and Terry Gaffney. That is announcement of the meeting. And I was supposed to give the lecture about the presentation of Cidinha work, Cidinha work in Singularity. And so Isabelle and Maria Carmen were also, we were three, and I was the first one. I made a big mistake. I know Isabelle, she's there? No, she's not there. Okay, so I can say. In fact, as I think my English is very, very bad. You can see that. I don't speak English. I speak what we call Franglish, which is a mixture of French and English. So you can see very well. And so I without speaking with Isabelle and Marie Carmen, I decided to present in Portuguese. And it was not what they were expecting. They were expecting speaking in English for every people. Yeah, so they were very furious against me, but that's it. But she is not there, so no problem. And so, but I was very happy of this picture at the end of the presentation with Cidinha. And also there was this is mathematical connections of Cidinha. It's impressive. That is at 60th birthday. Can you see the mathematical connections of Cidinha at that time? Huh? So it is quite 20 years ago. And what is impressive is the number of people you can find on this. I tried to do that, but I don't know. Maybe somebody knows how to do that. No, you know? Ah, because I don't know. If it will be very nice to do that now. It will be huge. But so at that time, that was presented by people to this meeting. Sorry? Yeah. Okay, so that was the meeting in 2008. And then with Cidinha, we had the connection we had. We wanted to extend possibility of young people, and that was one of the main objective was taking care of young people. And so we applied for a USP Coffee Cube project. Cidinha was always trying to see what were the best way to obtain funds for attracting people and for young people, and not only for meetings, but also for postdoc or for long time visit. And so we got this USP Coffee Cube project in 2008. The list of people are not all from this USP Coffee Cube. We had other project later, and but certainly some people are missing there. But I put a list of some people who were funded by such a place. Yes, I forgot to say something very important before I come back. Sorry. Here. That speaking of paying for people, for young people, I succeeded to get the money to invite many Brazilian people, including young people. But I said to all Brazilian people, okay, I will pay for your travel, but you have to come in Marseille with a bottle of cachaça in exchange. And so we had a lot of cachaça bottles to the caipirinha. And it's Marcio Soares who made the caipirinha. And I think he made the biggest caipirinha in his life with all participants of this Congress. So you can imagine a caipirinha for all these people. Okay, so I come back. Yeah. Okay. So this is after the thesis of Nivaldo, we wrote a paper with based on a thesis on with expansion of some results, and that was in London, published in London. And then, as I said, Cidinha was always looking at the possibility of funds, and she discovered, and I think it was the first time that it was this program. This program is for visiting professor in Brazil, and a grant for the professor to come in Brazil and having students going to France or to other countries. We made for France, but it was also for other countries, and it was a CNPq program. And Cidinha told me, "Wow, we have to apply to this." When this appeared at the very beginning of this possibility of grants, and we applied, and we succeeded. So I was during 3 years. It was giving a possibility to go to Brazil for during 3 years during 3 months, and also giving possibility for young people from Brazil to go to France, to Marseille, to work with me. And so it was very fruitful for young people. And in fact, this was not only, so Cidinha wanted to do not only for ICMC, for USP, but also for University UFMG in Belo Horizonte, and also for Fortaleza. And so that was also very nice for people from Fortaleza to come to France, for young people. So that was, okay. This was a very nice program, but in fact, this program disappeared in, I don't know when it disappeared, but it was very governmental. That was the time of first Lula president. And then this program also helped me to meet Nancy Chacha-Poyas. Unfortunately, she was not able to come to this Congress, but she was the second co-tutel, the second I had with Cidinha, so the second co-supervision. And she worked on with Cidinha and myself on this determinata singularities. We have also many talks on many conferences on determinata singularities, and so we had some results that you can see here, and the minimality theorem for the minor number, and also we extended result of Ley concerning the consistency of the minor number. That was work of Nancy Carolina Chacha-Poyas. She's from Peru, and she is now professor in Itajuba, if I don't mistake. That is the passing of the thesis. So we were already aware of the way to give the jury on the Brazilian side and on the French side, so it worked without any problem. And so you can see there the jury with some people you can recognize as well. I don't know why I am so high. Is it true? Okay. And then we had also a paper together. Oh, I can see here, yes. Oh, I didn't know. It's easier than going. Okay. I didn't know that. Okay, so we had this paper in International Journal of Mathematics that you can see, extending as well results of the Nancy thesis. And this is another picture. It's not on that day. It was in 2018, a little later, with Nancy between Cidinha and myself. Oh, now I want to speak a little of Cidinha in and out of the office. So, excuse me that I have. Okay. So, as you know, in the office of Cidinha, first of all, when you were discussing with her, she was always thinking of an example. And she had, I don't know how she had a battery of examples. And each time we were thinking of a result, let's see on an example. And she was computing, calculating the example with a dexterity and a speed incredible. So I think everybody knows that. It was absolutely fantastic. And also, she was always, when you were there, it was always there were some people going, and she was presenting people. So that was already said by other people during the meeting. But she was always introducing somebody to another body and saying that they were able to communicate, to discuss about the subject, and then they disappeared, and letting people discuss between them. That was a way of, we say collaboration, but it's active cooperation and collaboration. And it was not collaboration for her. It was collaboration for the two people in front of her. And that was absolutely something very, very impressive from Cidinha, not only for colleagues from researchers, but between a student and researcher. And she was introducing students to researcher. You know that very well. And so that's also fantastic for the students. So that is when Hin, but also she was discussing when she was discussing, I don't know, yesterday I think it's Rao shown timetable of a day by Cidinha. I don't know how she was doing to remember all appointments, all meetings they had with people. And for me, I need a paper agenda. And but she was doing without missing any appointment. Even maybe I will say this later. Even appointments for the hairdresser or for Pilates, and always Gaspar was there, and on time for going to hairdresser, for Pilates, or for any places. So this is also very important to say. Oh, sorry, I need also to take my papers. I am like Nivaldo. Well, okay, so, and so, on this, I spoke of hairdresser, but in fact, Cidinha always take care of herself. In fact, I hope I can say that without any feminist movement saying, but she was elegant. And I think that is also a very important aspect of Cidinha. She was taking care of herself. And having meetings to the hairdresser or going to Pilates classes, that was also something very important for her. And I want to emphasize also this point. Okay, so sorry. Well, so I want also to show favorite restaurants of Cidinha. Certainly, some of you know very well. The Mamei Natureza, which is a very favorite restaurant, and also the one we came yesterday night, where she was going very often on the Sunday. So we were going there to the restaurant in Ufskar, the one we were yesterday. So here is, I am arriving to, oh my God, I am going too fast. That is the last paper by Cidinha. In fact, when she was going to hospital in São Paulo, we were discussing this paper that we made together with Thuy. Thuy is a professor in university in São José do Rio Preto. And we were discussing this paper. We had some comments from the referee. And when she was going to hospital in São Paulo, we discussed by WhatsApp about this paper. And so unfortunately, she passed away in the weekend. And so in fact, it's we published in Dalat in Vietnam. That was scheduled, but the people we wanted to. We said that Cidinha passed away, and they wanted to put her name in a square. I don't know why, but it is in Vietnam. It is the rule apparently. But so this is this last paper that we wrote with her, and so it's also a very emotion for me that I am sure I am not the only one. I know that there are many papers Cidinha was writing at that time, and so maybe it will be too good to collect to see all these papers who were published later, and maybe I give some the only mathematical part. I will say some words about this last paper by Cidinha. And so there were two questions. about Bi-Lipschitz equivalence. And Bi-Lipschitz was mentioned a lot by Raoul and Thais. The first question is, does the Bi-Lipschitz type of map gem from Rn to Rp determines the Bi-Lipschitz type of the link of F and the double point set of F? That is the first question. And the second, reciprocally, given a map, do the Bi-Lipschitz types of the link and of the double points determine the Bi-Lipschitz type of the gem? And so we were looking at these two questions. We have some partial result, and that is maybe interesting questions that some people can continue, because I think we did not close completely. In fact, concerning the first question, we gave a positive answer. In the case of a finitely determined map gem, okay, with the condition P bigger or equal to 2n minus 1, you know that some people mentioned that Cidinha was aware of these nice dimensions, and so you can recognize here. And concerning the second, the reciprocal, we had a less result. We have only a partial result for a map gem from R2 to R3. Yeah? And we show that inner Bi-Lipschitz equivalence of a gem is guaranteed by equivalence of the links, image of the double point set, but you have to add also the polar curves of a generic projection. Okay, so if you the equivalence is guaranteed by these three, and in particular, if you have a homogeneous parametrization, I know that she liked Cidinha liked a lot this homogeneous case. And then we don't need equivalence of image of the double point set to guarantee Bi-Lipschitz equivalent of the gems, but it goes. So there are partial results, and I think that is a good hint for people who wanted to work in this area to continue this subject. So it's the reason for which I wanted to show this last result we had together. And Cidinha made me some surprise for me. She was very, very kind, and I have one surprise. Oh, maybe I have to take this away. It's not a striptease. So this is a T-shirt given by Cidinha. I will put away. Sorry. I cannot go for striptease in a cabaret. I am not good for that. Can you hear me? It's okay? Okay. So she gave me this T-shirt. I don't know if you can see from away. So it is, of course, in Portuguese. O mais brasileiro dos matemáticos franceses. I think you can understand. The most Brazilian of the French mathematicians. And she gave me this for my 70th birthday. And before that, for the 60th, I have to say that for my 60th birthday, she organized a small meeting here in USP, and she invited all people, many people from IMPA. There was Camacho, there was Paulo Sad, there was Marcio Soares from Belo Horizonte who came. So it was a small meeting with very friendly people here for my 60th birthday. For the 70th, they offered me this, and I am very proud. I know that Osamu has a similar one for Japanese. So it's unique on the French side, but it's not unique because Osamu has also such a T-shirt offered by Cidinha. And then there was this last year. Last year there was this mini workshop. Of course, Cidinha was not unfortunately. And but organizers, they continue. In particular, Miriam and Regilène and Thais, they organize this small mini workshop every 2 years. Odd years, you have this mini workshop, and as I more or less, I think the first day, maybe, they told me that Cidinha made some surprise for me. And I was very, of course, what is surprise? Because they have already a t-shirt. What can be the surprise? And the surprise was something fantastic that they, in fact, Cidinha organized. And it's a pity she did not see that, but she organized for me a medal of honor of University of São Paulo. So I got this medal as a present from Cidinha. And that was a lot of emotion for me. And in fact, this medal is recognizing relationship with the Brazilian Singularity community. And I'm very proud of this medal, and I want to show you because it's not a medal for my mathematical results, but a medal from relationship with people. And that for me, much more important, relationship with people than having mathematical results. And so it was a big emotion for me to receive this medal. And also I had, as you can see, I had to rent a costume and a tie that I don't have in general. But you can see Regilène, Miriam, and also Eliris from Rio Claro here. And also, as I said, Cidinha, when she was also speaking of a lot of family, and she was speaking of many things, music and so on, but family was important, and she was always speaking of the children, Juliana, Jana, I never succeed to say Janaïa, and José Carlos, and so she gave me also this viewpoint to that family is something important, and in fact, at this ceremony of medal, there was my grandchild. She's doing a master in São Paulo in law. And so my grandchild was there, and I want, as Cidinha was sharing family, I want to share also with you family. Okay, so thanks for the moment. Thank you.
Okay, thank you very much for sharing your great experience with Cidinha. Yes. So do you have any comments? Maybe no questions, but if you have some questions. No? Yeah, please.
Just to clarify, I meant that the 2008 video is available now with the English subtitles. Okay?
Okay, you tell me. Okay.
Okay, thank you. Any other questions or comments?
So I will continue. It's not finished.
Okay.
Okay.
Okay, then let's thank the speaker again. Thank you.
So we are in this wonderful workshop, and I have always to look at here. It's a I want to say first of all, this workshop is a part of events, and you know that there will be the school, and I will let Thais to present the school. Aurelian Menego was supposed to do, but he had to leave, unfortunately. Oh, you have the, okay.
As Professor Bracelet told us, when we start to discuss the organization of the workshop, we also think about a school of singularity theory, and the school is going to be held in Sweden University in Sundsvall at the end of August. We are going to have 3 courses, lectures, and posters too. And as I told you, the conferences are taught together, both of them. So the scientific committee is the same, and the organizing committee, some people of the organizing committee of the workshop is also in the organizing committee of the school, okay? So you are all welcome if you would like to attend the school too, okay? Thank you very much.
Thank you, Thais. So I think now we can thank all people. First of all speakers. You have the list of speakers there, okay? And all participants. So first of all, I would like you to thank all speakers to this workshop. I want also something which is not always done, to thank all people presenting posters. So the scientific committee, of course, who made a lot of work. And I asked people of the scientific committee to come with me. There is nobody from the scientific committee? Come with me. Yeah. There is also an organizing committee, so come with me. The students, where are the students? Come. 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 I don't forget people from the event sector of the ICMC. Marilia, come on. I have to say that I discovered something that I did not know about Marilia, is a sewing skills. And I did not know that she was mask maker during the COVID. And there is a video that you can see on your computer where Marilia explained how to do masks for the COVID. Yeah. So you can see that, and she's a expert for sewing. And also you have our photographer. Where is Reynaldo? Disappear? You have to ask him. So, in fact, Elton is the third people at the reception desk, and Fernando is responsible for this event sector. So now I will ask you something that is, sorry, Cidinha is an exceptional person. We have said that during all the week, and as I see, when people die, very often people they say things they were marvelous, they were very good, and it is completely fake, because at the same time that people say that they are marvelous, they are thinking, oh, this was a very bad guy, But so it is not sincere. And all has been said during the week was absolutely sincere. All we have said about Cidinha is completely sincere, from heart, and so we can say that. So she was exceptional, and for exceptional people, I will ask you something exceptional, to stand up, everybody, and to applaud for Cidinha. Thank you for Cidinha. Thank you. Thank you. De nada.
Please, I would like to remember you that we will be waiting for you next workshop here, okay? You and all your collaborators will be welcome to the next edition. Thank you so much.